So 4.4 is factoring polynomials. A factorable polynomial with integer coefficients is factored completely, meaning you can't factor anymore when it's written as a product of unfactorable polynomials with integer coefficients. So factoring polynomials, you still use like a lot of the same strategies as you would factoring quadratics. Just usually there's like a few extra steps, whether it's like pulling out GCF or like factor by grouping instead and stuff like that. So this would typically be a warm-up like in the classroom. So you're welcome to pause it here if you want. If not, you can just kind of like follow along with like regular notes. But we're going to factor each polynomial completely. So one big thing, especially like when you're factoring polynomials, so something like higher or something like with an exponent with higher power than 2. So you always for sure want to check for GCF first. So you really like always do, but especially here it'll really help out. So for number 1, x cubed minus 4x squared minus 5x. So if we check for greatest common factor first, we can pull out an x because everything at least has an x to the first power. So that's what I'm doing. I'm factor out an x first. When I factor out an x, x cubed becomes just x squared. Negative 4x squared becomes just negative 4x, and then negative 5x just becomes negative 5. So when you factor out the x, it has to stay out in front, but at least makes it a little bit easier to factor. So now the coefficient of x squared is 1. So if I want to factor this, I'm just looking for factors of negative 5 that add up to negative 4. So those factors would be negative 5 and positive 1. So multiplies to negative 5 adds up to negative 4. So that means that this factors into x times, it'll be x minus 5 times x plus 1. And then for number 2, 3y to the 5th minus 48y cubed. So we'll check for greatest common factor first. I know that I can divide everything by 3, and then I can also pull out at least y to the 3rd power because that's the lowest power on y that each of the terms has. So I can pull out a 3, and then I can pull out a y cubed also. So when I factor the 3y cubed out of 3y to the 5th, you're just left with y squared. You're basically like dividing it out. Factoring is just like doing the opposite of distributing. So I'm left with y squared, and then negative 48y cubed divided by 3y cubed turns into negative 16. So y squared minus 16. So now I have 2 terms here. So if I have 2 terms, I want to check to see if it's a difference of squares. And it is, because like 16 is just 4 squared. So difference of squares, remember, is that pattern. Like if you have a squared minus b squared, that factors into a plus b times a minus b. So if I want to factor this completely, I need to bring down the 3y cubed. And then if this is a squared minus b squared, that means that just a would be y and just b would be 4. So it would be y plus 4 times y minus 4. So 3y, sorry, this should be a 3y cubed. 3y cubed times y plus 4 times y minus 4. And then number 3, so 4z or 5z to the 4th plus 30z cubed plus 45z squared. So we can pull out greatest common factor. They're all divisible by 5. And each term has at least z squared, so I can also pull out a z squared. So 5z to the 4th divided by 5z squared, you're just left with z squared. 30z cubed divided by 5z squared, you're left with 6z, so plus 6z. And then 45z squared divided by 5z squared, you're left with 9. So this is actually like a perfect square trinomial, like something that we would create from completing the square. But if you don't recognize that, still the coefficient of z squared is 1. So whenever it's just 1, you're looking for factors of c that add up to b. So the factors of 9 that add up to 6 would just be 3 and 3. So if we want to factor this completely, we'll bring down the 5z squared. And then because we got the same like 2 factors, just 3 and 3, we can write this as z plus 3, either z plus 3 times z plus 3, or you can just do z plus 3 squared, which would be the most simplified way to write it. And then for 4, x cubed minus 7x squared plus 10x, so check for greatest common factor first still. So each of these has at least x to the first power, but there's no number that I can factor out, so I'll just factor out an x. So when I factor out the x, I'll be left with x squared minus 7x plus 10. And then the coefficient of x squared is 1, so whenever that's the case, we're just looking for factors of c that add up to b. So factors of negative 10 that add up to negative 7, it would have to be negative 2 and negative 5. So if we factor completely, this x comes down, and then it factors into x minus 2 times x minus 5. And then for 5, 3n to the 7th minus 75n to the 5th. So I know they're both divisible by 3, so I can factor out a 3 if we're looking for greatest common factor. And then I can at least pull an n to the 5th out of both terms since that's the lowest power of n. So I'll factor out a 3n to the 5th power as my GCF. And then 3n to the 7th divided by 3n to the 5th, it just leaves you with n squared. And then negative 75n to the 5th divided by 3n to the 5th leaves you with negative 25. So the n to the 5th completely cancel out. You're just left with negative 25 or minus 25. And then we have two terms. We want to check for a difference of squares, which it is because the 25 we know is just 5 squared. So going back to that pattern that we just talked about with the difference of squares, it's a squared minus b squared, which factors into a plus b times a minus b. So if we factor this completely, the 3n to the 5th will come down. And then a would just be n and b would just be 5, so it would be n plus 5 times n minus 5. And then for number 6, 8m to the 5th minus 16m to the 4th plus 8m cubed. So I know I can divide them all by 8, so I can factor out an 8 as my greatest common factor, but I can also pull out at least m to the 3rd from every term. So I'll factor out an 8m to the 3rd as my greatest common factor, and then 8m to the 5th divided by 8m to the 3rd just leaves you with m squared. Negative 16m to the 4th divided by 8m cubed is just negative 2m. And then 8m cubed divided by 8m cubed is just 1. So this is also technically a perfect square trinomial, but if you don't recognize that, the coefficient of m squared is just 1. So we're just looking for factors of positive 1 that add to negative 2. So those factors would just be negative 1 and negative 1. So if we want to factor this completely, the 8m cubed comes down. And then this factors into 8m cubed and then m minus 1 times m minus 1. Or you can write it as m minus 1 squared, since there's two of those same factors. Okay, so we talked about like difference of squares. There is also something called the sum and difference of cubes. So unfortunately, this is kind of one of those things that you do really just have to memorize is this pattern. But I mean, at least if this is remote, then you can kind of write it down if you really want to. So the sum of two cubes, so when you have a cubed plus b cubed, that factors into a plus b times a squared minus ab plus b squared. And then if you have a difference of two cubes, so a cubed minus b cubed, that factors into a minus b times a squared plus ab plus b squared. So for example 3, if we want to factor these completely, so we have x cubed minus 125, which is also a perfect cube. So I could write this or rewrite this as x cubed minus 5 cubed, because 5 times 5 times 5 is 125. And then we can see, like, okay, I have a difference of cubes. A is going to be x, b is going to be 5. And then we're basically just substituting a and b into this formula. So x for a and 5 for b. So it's a minus b, so x minus 5 times a squared, so it'd be x squared, plus ab, so a times 5, so plus 5x, or sorry, x times 5, so plus 5x, and then plus b squared, so plus 5 squared, so plus 25. So x minus 5 times x squared plus 5x plus 25. And then this always looks like it can be factored further, but it really can't, because you're looking for, like, it'd be factors of 25 that add to 5, which that doesn't exist. And then for b, 16y squared plus 16y to the 5th plus 54y squared. So you check for greatest common factor. I know I can divide them all by, like, at least by 2 because they're both even. And then if I divide, like, 16 by 2, I get 8. But if I divide 54 by 2, I get 27. So I can only pull out a 2. That's the biggest number that I can factor out, along with y squared, since each of them has at least y squared. So I'll factor out a 2y squared. And then 16y to the 5th divided by 2y squared is 8y cubed. So times 8y cubed. And then 54y squared divided by 2y squared, that would just become 27, so plus 27. And then now, like, 8y cubed is a perfect cube, and so is 27. It's 3 times 8 times 3. So I can rewrite this if you want, if it's, like, helpful. So 2y squared, and then 8y with, like, just the y being cubed. I can write that as, like, 2y in parentheses cubed. So 2y, like, all of this in parentheses cubed really means, like, 2 cubed times y cubed, which 2 cubed is 8. So these are the same thing. And then 27 I can write as plus 3 cubed. And then I can pretty easily see, like, what a has to be and what b has to be. So a would be just 2y, and b would be 3. So if I want to factor this completely, I need to use, like, that pattern. So the 2y squared will just come down. And then a sum of 2 cubes, so a cubed plus b cubed, like we have, that factors into a plus b. So it'll be 2y plus 3 times a squared. So 2y in parentheses squared, if you, like, want to do this off to the side, you can. It would be like 2y squared. That's the same thing as 2 squared times y squared. So 2y in parentheses squared, if we were to simplify it, it would be 4y squared. So that means that a squared from the pattern itself would be 4y squared, because we're squaring the 2y. So 4y squared, and then minus ab. So minus 2y times 3. So 2y times 3 is 6y, so it'd be minus 6y. And then plus b squared. So b squared was, or b was 3, so b squared would be 9. So plus 9. So 2y squared plus 2, or sorry, times 2y plus 3 times 4y squared minus 6y plus 9. And then same thing, like, this trinomial kind of looks like it could be factored further, but you'd be looking for factors of 4 times 9, so 36, that add up to negative 6, and those also don't exist. So example 4, it just says, again, factor each polynomial completely, so this would be a good time to, like, pause and try these ones on your own, because they're very similar to the ones right above. If you are ready, just push play. So example 4a is a cubed plus 27. So this is also a sum of cubes. I can rewrite 27 as a cubed, as 3 cubed, so it'd be a cubed plus 3 cubed. So it means a would be a, that's convenient. B would be 3. So if it's the sum of cubes, the first of the two patterns up here, that factors into a plus b. So it'd be a plus 3 in this case, times a squared, so just a squared again, minus ab, so minus a times 3 be minus 3a, plus b squared, so plus 3 squared plus 9. So a plus 3 times a squared minus 3a plus 9. And then for b, 6z to the 5th minus 750z squared. So you can check to see like if you could divide 750 by 6. And you can, so you can at least factor out a 6. And then you can also factor out a z squared, since they both have at least z squared. So if I factor out a 6z squared, 6z to the 5th divided by 6z squared becomes z cubed. And then negative 750z squared divided by 6z squared, that was negative 125. And then again we have, so z squared is obviously a cube, and then 125 is also a cube because it's 5 cubed. So if you want, you can rewrite it as 5 cubed if it helps you see what a and b would be. So 6z squared times z cubed minus, instead of 125, I would write it as 5 cubed. And then you can see that a is z and b is 5, and this is a difference of cubes. So difference of cubes factors into a minus b, so we'll just bring down this 6z squared. So a minus b would be z minus 5 times a squared, so in this case it would be z squared, plus ab, so plus z times 5 would be just plus 5z. And then plus b squared, so plus 5 squared plus 25. So 6z squared times z minus 5 times z squared plus 5z plus 25. And then the next section, or the next few examples, talk about factor by grouping. So it says for some polynomials, you can factor by grouping pairs of terms that have a common monomial factor. And the pattern for factoring by grouping is written below. I try not to focus too much on it, and we'll just kind of like talk through the actual example. So example 5, factor z cubed plus 5z squared minus 4z minus 20. So we have 4 different types of terms here. There's no greatest common factor other than 1, so I can't factor anything out. If I have 4 different terms, that's when you want to factor by grouping. And factor by grouping is when you kind of like split the expression in half and factor the greatest common factor out from each like pair. So between z cubed and 5z squared, the greatest common factor would just be z squared. So z cubed divided by z squared would just be z, and then 5z squared divided by z squared would be 5, so plus 5. And then between negative 4z and negative 20, I can factor out a negative 4. So negative 4z divided by negative 4 would just become positive z, and negative 20 divided by negative 4 would be positive 5. And that's what you want. You want these two to be the same. If they're not, like if the signs are messed up, say you only factored out a positive 4, you'd want to go back and change it so that the signs match up. And then now we'll pull the z plus 5 out of both of these terms. So we'll factor that z plus 5 out, and we're left with z squared minus 4. But you have to see if it's like fully factored. So when you are looking at factors that have like 2 terms, if you have 2 terms, you're looking for a difference of squares. So z plus 5 is not a difference of squares, it's just like z to the first power, but z squared minus 4 is. So that means like a, if we're looking at the difference of squares pattern, like a squared minus b squared factors into a plus b times a minus b. That means that a would be z, and b would just be 2, since 4 is 2 squared. So the z squared minus 4 can be factored further. So the z plus 5 will come down, so z plus 5, and then z squared minus 4 factors into z plus 2 times z minus 2. And then for example 6, it's just based off the last example. So factor each polynomial completely. You'll look at both of these and they both have like 4 terms. So it's kind of an indicator that you might need to do factor by grouping, but always check for greatest common factor first. So for A, x cubed plus 4x squared minus x minus 4. There's no greatest common factor other than 1 that I can pull out. And there's 4 different types of terms, so I'm going to factor by grouping. So we'll split the expression in half. The x cubed plus 4x squared, the GCF between those two is just x squared. So x cubed divided by x squared, that's just x. And then 4x squared divided by x squared is 4, so plus 4. And then between negative x minus 4, I can factor out a negative because I want the signs that are matching like the x plus 4. So I'll factor out a negative 1. And then negative x divided by negative 1 becomes positive x, and negative 4 divided by negative 4 becomes, negative 4 divided by negative 1 becomes positive 4. So these are the same, which is what we want to do. We're going to factor out the x plus 4 and x plus 4 out of both of these. So that leaves us with just x plus 4. And then the x squared minus 1 becomes our next factor. So x squared minus 1, and then always check to see if it can be factored any further. X plus 4 can't because it's just x to the first power. But x squared minus 1, it's a difference of squares as well because 1 is 1 squared. So this factors in that same pattern, like a would be x, b would be 1, so it would factor into x plus 1 times x minus 1. So the x plus 4 will come down, and then because this is a difference of squares, it'd be just, if a squared is x squared, just a would be x, b would just be 1, so x plus 1 times x minus 1. So x plus 4 times x plus 1 times x minus 1. And then for b, 3y cubed plus y squared plus 9y plus 3. So there's no greatest common factor other than 1 that I can pull out. So, and there's 4 different terms, so I should do factor by grouping. So I'll split the expression in half. So 3y cubed plus y squared, I can factor out a y squared. And then 3y cubed divided by y squared, you're left with 3y. And y squared divided by y squared, you're left with 1. And then between 9y and 3, you can factor out a 3. So plus 3. And then 9y divided by 3 is 3y. 3 divided by 3 is 1, so plus 1. Each of these terms both have a 3y plus 1, so I'm going to pull that out. So 3y plus 1, and then I'm left with the y squared plus 3. So times y squared plus 3, and then check to see if it's factored any further, or it can be. So 3y plus 1 can't, y squared plus 3 can't either. It's not a difference of squares here. So 3y plus 1 times y squared plus 3. Okay, so this next part, an expression in the form a squared plus b plus c, where u is an algebraic expression, is said to be in quadratic form. The factoring techniques you have studied can sometimes be used to factor such expressions. So this is just kind of getting into even like higher powers at times and factoring them using the same strategies. So for 7a, it's 16x to the 4th minus 81. So this looks like it might be a difference of squares, because it's, I mean, we have difference, we have two terms here. We can check for greatest common factor, but it doesn't look like there is one that we can pull out between 16 and 81, and 81 doesn't have like any x's, so we can't factor out any x's. So if we check for difference of squares, I know I can rewrite 16x to the fourth as like something being squared, and 81 I can as well. So 16x to the fourth is actually 4x squared being squared. And then 81 I can rewrite as 9 squared. So just in case that's confusing, so 4x squared in parentheses being squared means, since this is just one term in here, like different factors, so the 2 can go to each of those factors. The squared can go to both those factors. So it'd be 4 squared times x squared squared, which when you're raising a power to another power, you multiply those exponents, so x squared squared becomes x to the fourth. And then, of course, the 4 squared is 16, so 16x to the fourth. And then now you can see this is a difference of squares. It's a squared minus b squared, so a would be 4x squared and b would be 9, so a plus b would be 4x squared plus 9 times 4x squared minus 9 for a minus b. And then check to see if it could be factored further. So 4x squared plus 9 can't. There's no like sum of squares or anything pattern, but the 4x squared minus 9 can, because this is another difference of squares. So I'll rewrite this. The 4x squared plus 9 will just come down, but for the 4x squared, I can rewrite that as like parentheses 2x in parentheses squared, and then minus 3 squared for 9. So like 2x in parentheses squared is 2 squared times x squared, so 2 squared is 4, and then x squared is x squared. So another difference of squares, we can see like this time a is 2x and b is 3. So this 4x plus 9 will just come down, so 4x squared plus 9, and then a plus b would be 2x plus 3. So then a minus b would be 2x minus 3. And then for b, 3p to the 8th plus 15p to the 5th plus 2p. So we can factor out at least a 3, everything is divisible by 3, and then we can also factor out a p squared. So the GCF would be 3p squared, and then 3p to the 8th divided by 3p squared would be 3p to the, p to the 6th. And then 15p to the 5th divided by 3p squared, you'd be left with, so 15 divided by 3 is 5. And then p to the 5th power divided by p squared, that would leave you with p cubed. And then 18p squared divided by 3p squared, so 18 divided by 3 is 6. And then p squared divided by p squared cancels out. So we have p to the 6 plus 5p cubed plus 6. So factoring this is no different than factoring, say, like x squared plus 5x plus 6. So like we know with x squared plus 5x plus 6, this x would get broken down into, it'd be x and then plus 5, or sorry, x plus 2, times x plus 3. So if we're just factoring the x squared plus 5x plus 6, we're looking for factors of 6 that add up to 5. So it'd be x plus 2 times x plus 3. So that same strategy works here. It's just instead of breaking down x squared into x and x, we're breaking down p to the 6 into p cubed and p cubed, because they're going to add back up to this 5p cubed. So the 3p squared will come down, and then the p to the 6th power will break down into p cubed, and then the factors of 6 that add up to 5 would still be 2 and 3, so that doesn't change. So it'd be p cubed plus 2 times p cubed plus 3. So like I said, same thing, instead of just like the x squared getting broken down into x times x, the p to the 6 breaks down into p cubed times p cubed, because if we were to like check this by foiling, we do p cubed times p cubed, which is p to the 6, p cubed times 6, so 6p cubed, 2 times p cubed, so 2p cubed. Oh wait, sorry, excuse me, this should be a 3. I don't know where the 6 came from. This should be a 3. So p cubed times 3 is 3p cubed, and 2 times p cubed is 2p cubed, so those add up to the 5p cubed, and then 2 times 3 gets us back to 6. And then you can check to see if these can be factored further. They both just have 2 terms, so if you have 2 terms, you're checking for difference of squares. So they're obviously both not a difference of squares, so this is factored completely as is. So try, like, don't worry too much about like when you get higher powers. It's just gonna kind of like that first exponent basically just gets broken in half. So the p to the 6 gets broken down into p to the 3rd times p to the 3rd. And then for example 8, same thing, it's like based off these ones, so if you want to pause it here, you can. So factor each polynomial completely, negative 16n to the 4th plus 625. So we have 2 terms here, and like, but we have a sum, so there's no like pattern for a sum of 2 cubes, but we can factor out a negative to make it a difference because of this is like a negative 16n to the 4th. We can check to see if there's anything else we can divide, but like 625 isn't even, so there's really no number that there's a common factor. So we can just factor out a negative 1, and then that flips the signs. So if we factor out a negative 1, it turns into 16n to the 4th and then minus 625. And then we can start thinking about if it's a difference of squares. So like 16n to the 4th, I can write that as something being squared. And then 625 is 25 squared. So I'll leave that negative 1 out in front. And then 16n to the 4th, I can write as 4n squared in parentheses squared. So same thing, it's like 4 being squared, which is 16, and then n squared being squared to get us to n to the 4th. And then 625, I can rewrite as 25 squared, so minus 25 squared. And then we can see what a and b are, so a would be 4n squared, b would be 25, and I know difference of squares factors into a plus b times a minus b. So minus 1, and then times a plus b, so 4n squared plus 25 times 4n squared minus 25. And then we can check to see if there's a difference of squares again. So like this is a sum, there's no pattern for a sum of squares, so that will just stay the same. But the 4n squared minus 25, that's another difference of squares. So I'm going to rewrite it. I'm just going to bring down the negative 1 times the 4n squared plus 25. And then 4n squared, I'm going to write as 2n in parentheses squared. And then the 25 I can write as 5 squared. So minus 5 squared, and then we can see what the new a and b are for this difference of squares. So a would be 2n, b would be 5. So we'll bring down the negative 1 times 4n squared plus 25. And then times a plus b times a minus b, so a plus b would be 2n plus 5, and a minus b would be 2n minus 5. And then for b, 5w to the 6 minus 25w to the 4th plus 30w squared. So everything's divisible by 5, so I know I can factor out a 5 as my GCF, but I can also factor out w squared. So I'll pull out 5w squared as my GCF. So 5w to the 6 divided by 5w to the square, or 5w squared, just leaves you with w to the 4th. Negative 25w to the 4th divided by 5w squared leaves you with negative 5w squared. And then 30w squared divided by 5w squared leaves you with 6, plus 6. So now, same thing, like, even though it's w to the 4th, like, this coefficient is 1, so we're just looking for factors of 6 that add up to negative 5. So it would have to be -2 and -3. And then when I factor this, I'll just bring down the 5w squared. And then because this is w to the 4th power, it's going to break down into w squared and w squared. So one factor would be w squared minus 2. And one factor would be w squared minus 3. You can always check by foiling, like w squared times w squared is w to the 4th, w squared times -3, and then -2 times w squared would get you back to -5w, and then -2 times -3 is +6. And then check to see if it could be factored further, like, is this a difference of squares? So 2 is not a perfect square, and neither is 3, so this can't be factored any further. So it's just 5w squared times w squared minus 2 times w squared minus 3. And then the next kind of theorem that we're going to talk about is, so polynomial f of x has a factor of like x minus k if and only if f of k equals 0. So we're going to go back to using synthetic division. So what's cool about this is like sometimes like you can't really factor something initially, but using synthetic division gets you to a point where you can factor it further or fully. Okay, so example 9, it says determine whether x plus 5 is a factor of f of x equals 3x to the 4th plus 15x cubed minus x squared plus 25. So if we want to check to see if x plus 5 is a factor, we're going to use synthetic division with k equals -5 because this is x plus 5. So like if we're comparing it to like x minus k, it would be x minus -5 to turn it into a plus 5. So to check that, we want to set up like that little kind of like upside down division bar for synthetic, and then our k value goes in the upper left, so -5 goes in the upper left, and then our coefficients go across the top, so 3, and then 15, -1, we skip x to the 1st power, so we need to include the 0, and then 25. So we'll bring down the first number, the 3. -5 times 3 is -15. Add this column, 15 plus -15 is 0. 0 times -5 is 0. -1 plus 0 is -1. -1 times -5 is +5. Add this column, 0 plus 5 is 5. And then 5 times -5 is -25. So 25 plus -25 is 0. So we got a remainder of 0. So if we get a remainder of 0, the theorem said a polynomial f of x has a factor of x minus k if and only if f of k equals 0. So like one of the last theorems that we did said that like the remainder is also like the function evaluated at our k value. So like f of -5 is 0. So if that's the case, then x minus k, in this case x plus 5, is a factor, and then these are all what's left. So like if I wanted to factor this further, I would change this, so it'd be f of x equals, and then I would rewrite this as a factor, as a product of two factors. So I just proved that x plus 5 is a factor, so that would be one of them, so x plus 5. And then the other factor is what's left after you divide. Because like factoring is just like, you're dividing basically, we're factoring out that x plus 5. So 0 was the remainder, 5 is the constant, -1 is the coefficient of x, 0 would be the coefficient of x squared, and then 3 is the coefficient of x cubed. So it's x plus 5 times x cubed plus x, or sorry, not plus 0 x squared because it's just a placeholder, and then minus x, so 3x cubed, 0x squared, we don't need to write that, negative 1 times x, so just minus x, and then plus 5. Sorry, this should be x cubed. So x plus 5 times 3x cubed minus x plus 5 if we needed to factor it further. So just determining if it's a factor or not, you just want to get a remainder of 0 basically, but if you wanted to factor it further, that's how you would. And then for B, show that x plus 3 is a factor of f of x equals x to the 4th plus 3x cubed minus x minus 3. So same thing, and then if we want to factor it completely, we will like we did above. So if we're showing that x plus 3 is a factor, that means that k is going to be negative 3, since it's like x minus k, so x minus negative 3 turns into plus 3. So I can set up my synthetic division. So across the top would be 1, 3, 0 for x squared, and then negative 1 and negative 3. 1, 3, 0 as a placeholder for x squared, and then negative 1 and negative 3. And then the k equals negative 3 goes in the upper, like outside left. So we bring down the first number, bring down 1. 1 times negative 3 is negative 3. Add that column, 3 plus negative 3 is 0. 0 times negative 3 is 0. 0 plus 0 is 0. 0 times negative 3 is 0. Negative 1 times 0, or sorry, negative 1 plus 0 is negative 1. And then negative 1 times negative 3 is positive 3. And then negative 3 plus 3 is 0. So we ended up with a remainder of 0 again. So that proves that it is a factor. And then if we want to factor it completely, we can pull out the x plus 3, and then this is what we're left with. So the remainder was 0. That next number over is going to be our constant. So our number without a variable. The 0 would be our coefficient of x to the first. The next 0 would be our coefficient of x squared. And the 1 is our coefficient of x cubed. So if we're factoring this completely, we can rewrite it as f of x, and then if we pull out the x plus 3, if we factor out the x plus 3, we're just dividing it out of f of x, and if we divided this out, this is what we're left with. So 1x cubed, so times x cubed, 0x squared, 0x, and then minus 1 is our constant. And then you can check to see if it can be factored further, and it can, because this is a difference of cubes. So this is a difference of cubes, so A would just be x, and then B would just be 1. So the x plus 3 comes down. And then a difference of cubes factors into A minus B, so x minus 1. And then x squared, so times x squared, plus AB, so just 1 times x, so plus x, and then plus b squared, so plus 1. So f of x equals x plus 3 times x minus 1 times x squared plus x plus 1. And then for C, show that x minus 6 is a factor of f of x equals x cubed minus 5x squared minus 6x, and then we want to factor it completely. So like the previous two, if you want to pause this and try it on your own, wouldn't be a bad idea. So if we're showing that x minus 6 is a factor, that means that k is just positive 6, since it's like x minus k. So we can set up our synthetic division. So across the top would be 1, negative 5, negative 6, and then 0 for the constant. 1, negative 5, negative 6, and then 0, and then our k value goes in the outside left, so 6. We always bring down the first number, so bring down the 1. 1 times 6 is 6. Negative 5 plus 6 is 1. 1 times 6 is 6. negative 6 times negative 6 plus 6 is 0, and then 0 times 6 is still 0, and then if we add that column, 0 plus 0 is 0. So we got a remainder of 0, so that's what shows that it is a factor. And then what's left over once we factor that out is what we're given after we divide. So the 0 is, the next 0 is the constant. This first one, or the one on the right, is the power, or the coefficient of x to the first power, and then the second one is the coefficient of x squared. So if we want to factor completely, it would be f of x equals, once I factor out the x minus 6, that can go out in front. Factoring out is just dividing it out. So once I divided out the x minus 6, I was left with these values. So this is x squared. So x squared and then plus 1x. And then 0 was my constant, 0 was the remainder. So I have x minus 6 times x squared plus x. You kind of have to take it a little bit further because between the x squared and the x, there's a greatest common factor there of x. So we can factor out an x. So I'll bring down the x minus 6. If I factor in x out of x squared plus x, it'll come out. And then if I factored out x squared divided by x, just leaves me with x. And then x divided by x leaves me with 1. So it turns into x plus 1. And then I would just rewrite it with the x first. So f of x equals, we'll move just this like lone x to the front, times x minus 6 times x plus 1. So x times x minus 6 times x plus 1. And then the last example says during the first 5 minutes of a roller coaster ride, the function h of t equals 4t cubed minus 21t squared plus 9t plus 34 represents the height, h in feet, of the roller coaster after t seconds. How long is the roller coaster at ground level in the first 5 seconds? So here's a really good example of a time where using synthetic to factor something is very helpful. So if we look at the picture, this is showing the height, so it starts off below and then it goes above ground level and back down below. So we want to figure out how long it's above how long it's below ground level. We have to kind of figure out the x-intercepts. So we can see them, but some of them are hard to identify. So we can see there's one here at negative 1, 0. We can see there's one here at 2, 0, and then there's another one here, but it's impossible to tell exactly what that is. So if we want to try to figure that out, we can test the other x-intercepts to see if they are true factors, and while we're testing them using synthetic, we'll be left with the remaining factors basically. So if I want to test this first x-intercept, that's going to be my k value of -1, since the x-intercept is -1, so k equals -1. So I'm going to do synthetic division with my original function and with a k value of, -1. So -1 will go on the outside left, and then 4, -21, 9, and 34 goes on the inside. So I'll bring down my first number, bring down the 4. 4 times -1 is -4. -21 plus -4 is -25. -25 plus times -1 is +25. 9 plus 25 is 34. And then 34 times -1 is -34. And then 34 plus -34 is 0. So we get a remainder of 0. So that proves that this actually is a solution, this -1 for sure is a solution. And then if we factor out that x minus -1 or x plus 1, this is what we're left with. So the remainder is 0. 34 is my constant. -25 is my coefficient of, in this case it's t. And then 4 is my coefficient of t squared. But like you wouldn't be able to factor this any other way because it's not really like factorable by grouping because there's not like common factors there that you can pull out. So once I prove this, I can basically factor out like the x plus 1 or t plus 1. So it becomes h of t equals t plus 1 from evaluating at -1. And then what I'm left with is 4t squared minus 25t and then plus 34. And then if you want, you can like try to factor this as a trinomial, but we know like another probable x-intercept or solution, and that's at 2. So we can factor this, like just the 4t minus 25t plus 34, with that same method. So now if I'm checking the like solution of 2, like from this intercept, my new k value is 2. So I'm going to do another synthetic division that goes in the upper left. And then now I'm just using synthetic for the 4t squared minus 25t plus 34. So 4 goes across the top, and then -25, and then 34. So the first number comes down, so the 4 comes down, and then 2 times 4 is 8. -25 plus 8 is -17. And then -17 times 2 is -34. And then 34 plus -34 is 0. So we got a remainder of 0, so that proves that the 2 is actually a solution or a factor. And then the 17 or the -17 is my constant once I factor it out. And the 4 is my coefficient of just t to the first power. So we proved that, like, first we proved that t plus 1 is a factor by checking like k equals -1. And now we proved that t minus 2 is a factor by like evaluating or using synthetic for k equals 2. So this can be factored further into, it'd be t plus 1. And then the 4t squared minus 25t plus 34 factors into t minus 2 for the k equals 2. And then when I pull out that t minus 2, this is what I'm left with. So 4t minus 17. And then this 4t minus 17 is going to tell us what this like last intercept is. So we have h of t equals t plus 1 times t minus 2 times 4t plus 17. And if we wanted to like evaluate or figure out exactly what these x-intercepts were, or t-intercepts, we would set the function equal to 0, because like the y-coordinate basically is 0 anywhere on this axis. I guess it's h-coordinate in this case. So we could set each of these factors equal to 0. So 0 equals t plus 1 times t minus 2 times 4t minus 17. Set each factor equal to 0 to get our different solutions. So t plus 1 equals 0, t minus 2 equals 0, and then 4t minus 17 equals 0. So these are easy. Subtract the 1 over, get t equals -1. Add the 2 over, get t equals positive 2. And then for 4t minus 17, if we add the 17 over, we get 4t equals 17. And then if we divide both sides by 4, you end up with t equals 4.25. So that tells us exactly like what this value is. So this is -1, this is 2, this is 4.25 seconds. So now we can figure out like where exactly they're underground. So the ride itself, it goes underground between like these two intercepts, so between 2 seconds and 4.25 seconds, so for a total of 2.25 seconds. So the ride is underground between 2 seconds and 4.25 seconds. So for a total of 2.25 seconds.